In this lecture, we are going to talk about two very important storage classes. The first one is the automatic storage class, automatic variables, and we have got the keyword for that. It is called as AUTO, auto. And the second one is the external variable or external storage class, EXTERN. Extern is the keyword for the same. Okay, so first of all, let's try to learn what is the automatic variable or what is the auto keyword, how we use it. Now this is a very simple program already created here. The main function is here. Okay, I've declared one variable a, assigned the value 10 to it, and then I've printed the value of a here, and then I created a new block. So this is a new block. Always remember, block is enclosed within the opening brace and the closing brace. Okay, so inside the braces we can actually define a variable, right? We have already seen this in our previous lectures. Now in this block I've defined one variable b, and b is assigned the value 20. B is printed inside this block, and outside of the block I'm trying to print the variable a and the variable b. Okay, now let's try to compile this code and see what it does. So on compiling, if you can see here, it is telling me that there is an error in line number 18. This is line number 18, right? It says that b is not declared in line number 18. So what does it mean is that b is not available here in line number 18. B is defined in this block, so b will only be available inside this block. So we say that b is an automatic variable. So it is an automatic variable. So what do you mean by automatic is very simple. Now b is not there before this block and b will not be after this block. So if I try to print b before this block, let's try to print b before the b block begins. So let's try to print a value for b here. Okay, so before b block, b is this much, right? So let's try to compile this and see what happens now. Okay, so it says there is an error in line number 11 now. Okay, line number 11, I'm trying to print b before b is existing, right? So that is an error. B is not identified as of now. Okay, so b is only valid inside this block. So we say b is having the block scope. Okay, it is an automatic variable because b will come into existence. The memory will be allocated for b at line number 14, and once this block is exited or terminated at line number 17, this block is done. At that time, whatever memory was allocated for b is now deallocated. So after line number 17, b is not there in the memory, so you can't access b. So automatically the memory for the b is allocated when it is entered into the block. Inside this block, whenever it encounters line number 14, automatically the memory is allocated for b, and at line number 17, when the block completes, automatically the memory is deallocated or memory is deleted for b. Okay, so b is not there in the existence anymore. Therefore, line number 19, that is printing the value of b, will not work, and line number this 11 will also not work because b is not there at that point. Okay, so if I just try to compile this now and see what happens, we'll try to understand this in more details now. Okay, compilation is successful. Now there is no error. Let's try to run this. I see before b block, so this is b block. Before b block, value of a is how much? A is 10, as it is defined here. A is 10 and b is 20. So this b20 is being printed from the block b block. Okay, so inside this block b is valid. Okay, so b is 20, and outside of this block I'm trying to print a. Now a is defined in this block, in the block of the main function, so therefore a is also an automatic variable. Okay, so by default, whenever you are trying to define a variable inside the block, it will become by default an automatic variable, right? But if you want to manually make it as an automatic variable, you can also write auto int a. Okay, so auto int a and int a here are the same thing. Similarly, int b and auto int b, they are the same thing. So whenever I write auto, that variable becomes automatic variable. Okay, so by default it is an automatic variable, but if I try to create one global variable here, let's say int x. Okay, and let me assign the value of x as 10. Globally I'm assigning the value of x as, let me make it as 100. Okay, x is 100. Now what happens if I try to make this automatic? Can I make it auto? Let's see what happens. Okay, so if I try to make this auto, it says that the file scope declaration of x specifies auto, right? So you can't actually make the global variable automatic. Okay, so you can't make a global variable automatic, so I get this error. Okay, so automatic variables are having the block scope, not the file scope. right? So this X is a global variable. It is having the scope of entire in this entire file. So it is having the file scope. The scope of X is file scope. That means it is available in the entire area or the portion of the file of this program, right? That is automatic variables.c. But this variable A is local variable to the main function, right? It is an automatic variable. Automatically memory is allocated when this block is entered. It will be deallocated, so that memory can be used by some other variable, and that will be decided by your compiler and your operating system, right? So I hope you have understood that you can't make a global variable an automatic variable. Okay, we can just remove this one. So this is all about automatic variables. Now we'll learn about the extern variable. Now this extern keyword is useful whenever you are doing multi-file programming, meaning that in your program that you're writing, you are having multiple files, okay? Multiple source code files you are having. Maybe you have separated different functions are there in a different file and different modules are there in a different file. You may have a multiple file for a problem that you're trying to solve. In that case, extern is very much useful to refer to the variable that is externally defined in some other file. Okay, so let's take this example. I have this program called as extern.c, very simple program. I've got a variable A locally defined in the main function. I'm just printing the variable A in the main function. So I'll just write GCC, compile this code to see what it does, extern.c, and compilation is successful. I run this, I get that A is 10. Now let's say that I have one more file in this particular problem that I'm trying to solve, and that file is called as extern1.c. So in this file, I'm trying to define all my variables that I'll be needing for solving my problems. Okay, so let me have one integer variable x which is having the value 100 assigned to it. Okay, now this is a variable. I'm just doing variable declaration in this particular file. Okay, it is not just declaration, it is actually definition as well. Whenever I do int x equals to 100, this x will be allocated the memory. So this is called as definition, right? So definition is something which actually allocates the memory. In the memory, it will take the space, and then this variable x will be stored, that is 100 will be stored in that variable. Okay, so memory is occupied in case of definition. Now I've already defined this variable x in the file extern1.c. Now I'd like to use this variable x which is defined in extern1.c in the file extern.c. So in extern.c, let me try to print the value printf x equals to %d. I'm trying to refer the x that is defined in the other file. Okay, so I'm trying to print x. So I'm trying to, here I'll write the comment, refer to x defined in extern1.c. Okay, now let's try to compile this and see what happens. If I just write gcc extern.c, obviously I'm just compiling this source code, so it will not be able to find x in this file. So obviously it will tell me that there is an error, x is not declared. Now to solve this, what I can do is, while compiling, I can give both the file names. So gcc can take two file names as the argument. So gcc space extern.c space extern1.c. So I'm trying to compile both these files together. Okay, and trying to create the executable file. Let's see what happens. Now it says that although I am actually taking both the files together and compiling, it says that x is still not declared, right? Now x is defined in the file extern1.c. Now I need to declare x in this file extern.c. So I need to declare x in this file. Okay, so how do I declare x? I can write int x, right? Whenever I write int x, what happens is I'm actually defining a variable x, okay, globally in this file. Now let me try to compile this code after I have declared or defined the variable x in this file extern.c. Okay, now compilation is successful, right? Let me run this. Okay, I get the value of x as 0, and it is not taking this, so it is only referring to this x, right? This is a global x, so this I am defining x, so this is defining x. So this is a different x and this is a different x. And if I want to use this x that is 100 in this file, I'll have to declare x in this file. Okay, I need not define it. I don't want it to take a new memory. I would just want to declare it. So I write int x. If I write int x, it is definition. So if I want to declare it, and if I want to specify that this is an externally defined variable, I write extern just before int. So now the compiler will understand that, okay, there is this variable x which is defined somewhere else. Somewhere else it is defined in some other file outside of this scope of this file. So the scope of this file, there is no X defined. The X is defined in some other file and I'll have to refer to that. Okay, now if I try to compile this, okay, it should work fine. Okay, so I'll just write extern.c and extern1.c. I compile. Now compilation is successful, no error. I run this. Now I get X is 100, right? So this statement is declaration. Declaration is just like a reference. Okay, it's a reference to X defined in the file extern1.c. Okay, so it is not going to allocate the memory for X here in line number 6. It is going to refer to this X already defined. Okay, so I can do as many declarations as I want. I can write extern int X, extern int X, because it is just referring to the same variable multiple times. Does not matter, right? See, if I try to compile this again, no error, right? So I can do multiple declarations, but definition you have to do only once. Only once you will be able to allocate the memory for a variable. I can't write, int X equals to 100 here, int X equals to 200. If I do this, I'm trying to define it 2 times. Let's compile this. It will say that, okay, redefinition of X. So definition happens once and only once. Okay, and declaration can happen more than one time, as we have demonstrated here, right? So extern is very useful keyword whenever you would like to refer to a variable that is already being defined in some other file. In that case, we generally use the extern keyword, and extern helps us to declare the variable and avoid us doing the multiple definition of the same variable. And you can use the same variable that is defined in some other file easily by using a extern keyword. This is the use of extern keyword. So in this lecture, we have learned the use of automatic or the auto keyword and the extern keyword. We have demonstrated this with an example. I hope you have understood how it really works. That's all in this lecture. Stay tuned.